We have Dave Presshold, our sales manager for Profit Pro, and Jim Ladley's on. I heard David Widman's on from Profit Pro also, and Ken Hamilton from Biominerals Technologies will be our featured speaker tonight. And we're going to be discussing Goss's Wilt. Kind of the topic is, did you have Goss's Wilt in your corn in 2013? And if you're in the upper Midwest, I can almost guarantee you did, from what I've seen. If so, how much did it cost you in yield and in test weight? Some think that it cost the producer anywhere from 50 to 100 bushel per acre. I've talked to Doc Huber a little bit about this, and he wasn't able to be on tonight, but he was thinking 100 bushel is closer than the 50 bushel. He said it really, really hurt us in the upper Midwest. Tonight you're going to learn how to identify the disease and what to do to help prevent it. And we're also going to learn why the disease is becoming such a major concern in corn production in the upper Midwest. This will be one of the topics that we'll talk about at our winter conference on February 6th and 7th. And that's going to be at our headquarters in Albert Lea. There'll be 3 sessions. The first one will be on livestock and manure management on the 6th, and that runs from 9 to 12. There'll be session 2 will be on weather and markets, and then also on crop production. And that runs from 1 to 7:30, also on the 6th. And then on the 7th, be from 8 to 3:30, and that's going to be on crop production and Goss's Wilt. And that'll be Doc Huber and Ken Hamilton on that one. Session 2, I forgot to mention the speakers, will be Ken Hamilton and Larry Acker. And then session 1 will be on the manure management and stuff, will be Peter Sharpie and Ken Hamilton. Well, I guess let's just jump right into it. Goss's Wilt is starting to make a little bit of noise, even nationwide now. There was an article in the New York Times, let's see, September 30th, and they have a picture of Alton, Iowa, which is southwest Iowa, and they're talking about Goss's Wilt, and they have a picture. The plant leaves are just, they're brown, they're shriveled up. You can see the black freckles, if you will, and if you hold that leaf up to the light, you can see those freckles. You can see like water spots on those leaves. That's a good way to identify Goss's Wilt. And it will shut the plant down in a very short time if it's severe enough. I've seen, you know, up here in the Midwest, upper Midwest, I've seen plants shut down in 4 to 5 days, completely turning that plant into a pink color. It turns the leaves into a pink color for some reason up here in the upper Midwest. And nobody can really tell me why. I've talked to Ken on this too, and we have some theories, but we really don't know for sure why. They also spotted it all the way down in Louisiana this year. It's never been in Louisiana, so they weren't even sure what it was. They had to send it off to a lab to identify it. So it's becoming a major concern, and Ken's going to kind of discuss why it's becoming such a concern. So Ken, what has made Goss's Wilt such a bugger? I mean, why is it so much of a concern now? Why is it really hammering us when in the past it used to be a little wimp of a disease?
Hey, Dennis, can I chime in for just a minute?
Yeah, go ahead, Dave.
If anybody's sitting at their computer, go to google.com and Google Goss's Wilt, Gosswilt, and there's about 100 really good photos. The first thing that comes up. So while Ken is talking, you could be looking at some of these photos and see what he's talking about. There's some really good pictures there. So
sorry, Dave. I had 3 pictures I think we put on the teleconference announcement that most of you have gotten on your email. those are good pictures too, because they're showing this. I don't know if it's a new strain or not, but the pink leaves are what we see what we're seeing up in my area, North and South Dakota, central and western Minnesota. If you take those pink leaves and hold them up to the light, it's Goss's Wilt every single time, and it's all over the place. So, Ken, go ahead and take it away. Why is it such a major disease?
Well, in past decades, it has largely been controlled by beneficial organisms that had historically and were present in the soil. Over time, with the increase of herbicides and fungicides and insecticides, we have reduced the beneficial populations in our soil to now there is very little resistance to the pathogen populations escalating into the dominant biologies that are controlling our soils. A good example is your residue. From corn, it doesn't decompose. It has a very slow rate of decomposition, which means that the beneficial organisms that take care of that breakdown process simply aren't there. And so, especially with the GMO varieties, we have the glyphosate or the glufosinate or those insecticide type applications, herbicides that are applied that are so harmful to the beneficial microorganisms yet so stimulating to the pathogenic organisms. And so you've completely imbalanced that control factor in your soil to where now the control mechanism is virtually non-existent and the out-of-control pathogen dominance is taking over. And this is only going to get worse because as we continue to farm the way we're farming, everything that we're doing to cause these problems is only going to escalate. We don't have these problems because there's some accident out there. We have these problems because we created them. And we're going to have to go back and correct the situation if we're ever going to get away from these problems. And so when you look at the biology structure in a soil, you have to look at the soil as its own environment. If we destroy that environment, the beneficial microorganisms are the first to go. They are the most sensitive to the toxins, the harsh acid-based and salt-based fertilizers, and the chemical-based applications take them out very, very quickly. When we alter that environment, it shifts it in favor of the pathogens, and they can sporulate, they can protect themselves, they come back with a vengeance, and then they become this dominant group. And so we have actually created this monster by the farming practices that we've been sold by big agriculture and biotech. And yes, I realize that some of these products made life easy, but now the consequences of us not managing properly is coming back to haunt us in a big way. And these pathogens are getting more and more virulent. They are becoming resistant to many of the, I guess, antibiotics or the fungicides or the biocides that we try to use on them. And so they're clearly in control in some of these environments, and these plants don't have much of a chance of survival when we have eliminated all of the defense mechanisms of the plant, either through the good biology in the soil and the poor nutrition that our NPK programs offer the plant. These plants have some tremendous capacities to develop within themselves an immunity, but it's all nutrient-based, and it takes way more than NPK to address all of these functional systems in the plant. And yes, NPK are building components of the plant, but they're not primarily the plant's running or operating systems to develop immunity, reproduce seed, all of the nutrient transfer and the photosynthetic processes, largely driven by trace minerals. And so we have kind of used a two-edged sword here to kill the soil biology, reduce plant nutrients, and this was only a matter of time. It was as predictable as gravity. You destroy the soil environment, weaken a plant's ability to resist pathogens, and in time you have faltering crops that are losing a tremendous amount of their potential and a good part of their yield.
Now, Ken, what type of organism is Goss'S Wilt? Maybe we should explain that too.
Goss'S Wilt is a bacteria, and it is a gram-positive bacteria. It's only one of two gram-positive pathogens that come in here and beat up on corn. And it's a very, very persistent little guy in that we've created the environment that it does fairly well in. And so these gram-positive bacteria types, we're experiencing a very similar system out here in the Idaho potato market. Corn in your part of the world is king. Out here in Idaho, potatoes are the big crop. And we now have a sister organism to Goss'S Wilt that is causing a disease in potatoes called bacterial ring rot. That organism is what they call Clavibacter michiganensis serpentinensis. And of course, the organism in Goss'S Wilt is Clavibacter michiganensis nebraskaensis. And so they're both gram-positive. They're like kissing cousins. And we have seen a huge escalation in the disease in the potato market in the last 2 years in Idaho. And it is spreading because, as with corn or anything else, we don't have genetically modified potatoes that can deal with Roundup or other herbicides. But what the practice in the soils is out here is to apply some very harsh bactericides and fungicides and biocides, Vapam being one of them, which is really kind of like a nuclear biocide going into your soil. It destroys all the good guys, yet the pathogens survive from year to year. So now what we're seeing is millions of dollars worth of potatoes in one shed that can literally be disintegrated in 4 to 6 weeks, turned in from a solid potato into an oozing, vile mush simply by this organism, because it is in the seed, it's in the plant, it goes into storage, and it feeds on starch. And so these huge operations that have historically been very successful are taking some major hits and even going out of business because of this organism, and it's spreading. And so it's an alarming problem out here, because you lose the entire cellar. If you have condemnation, there's zero tolerance to this. If it's in the seed, it's all destroyed. And so there isn't a partial salvage. There's nothing to sell. It's a total loss. And
Ken, you mentioned something there that it destroys the starch from the potato. That's also what it does to the corn seed, is destroying the starch. Do you want to go into that a little bit?
It uses it as a food source. These microorganisms, what they're doing, whether it's in the potato or whether it's in the plant, when you look at what these organisms are doing to kill these plants is they get in the vascular system of these plants. And when you look at Goss's wilt on a corn leaf plant, for example, what you'll see is the sugars that the plants produce, what the microorganisms are doing, the pathogens are doing, is taking those sugars and they're converting them into large, sticky, heavy carbohydrate structures. When you look at Goss's wilt under the sun, you'll see this shiny stuff. It's like a dried varnish on the leaf. That was some of the plant nutrients that got converted to this varnish that is part of this plugging up of this vascular system. This is nutrients being diverted, and this is where pathogens become so deadly on these plants, is they play total destruction in these vascular systems, whether it's the xylem or whether it's the phlegm in the plant system moving nutrients or taking it up. They get in there and they plug them up. They use the nutrients intended for the plant. They grow and prosper, and then they use the food sources off of the plant, and there's no way you'll save the potato.
So what you end up with, Ken, then is premature death, and that just circumvents yield and test weight, doesn't it?
It does. They actually, depending on how aggressive and unchecked it is in the fields, you can actually have the plant die and the potatoes rot in the soil, and there's nothing to harvest. Now, in corn, it depends on whether you have, there's two particular symptoms of Goss's wilt in corn. One of them is the symptomatic wilt, where it just gets in the plant vascular system and it starts to plug stuff up. And the plant just simply wilts down, and it's starting to shut the plant down. Well, this stuff always comes here, tends to really hit the plants in late August, early September, and what we're doing is trying to fill an ear at that point. We're trying to translocate the nutrients from the soil that's coming through the root system. We're trying to translocate what's stored in the body of the plant into the grain, and we've seen this over and over. You'll walk a field in August, and you know that there's 250, 270 bushel there. When you harvest, you don't have it. And we didn't get this completion of transfer of nutrients. These organisms stop it, and what we see is in the wilt, it's shutting it down internally. But when you go to the late season foliar blight, which is what you can see on the leaves, the total destruction of the photosynthetic process is it's shutting it down from the outside as well. And the internal wilting is not as common as that external damage you see to the leaves, where it turns it the browns and the grays and the pink colors, and then you see the freckles and the frecking on there with the black marks. It's when that happens, we're losing our photosynthetic factory in the plant, and that's a big part of filling. That's a big part of that sugar and concentration going into that seed. And when these organisms shut that down, there's nothing that we can do except lose yield over this, Jim.
So now, Ken, let's say we have an infected field. We harvest it. We put it in the bin. Now, you talked about the potatoes in storage. What happens to corn in storage that's infected?
It's in the seed. It's going to go into the next field wherever it goes. Now,
so you're saying that that can we lose test weight in the bin? And then the other question would be, if I'm buying seed, are you also saying that I can buy infected seed? It can be right in the seed itself?
Oh, absolutely. Positively, absolutely. It is. There's no way that in the last couple decades, since they've really started monitoring this out of Nebraska and Michigan, or Minnesota, that it could spread from Colorado to Pennsylvania, from Canada to Texas. I mean, this is in the seed. It is being transported airborne, water, seed, all kinds of different ways. And what they're finding is when it's translocated in the seed, there's not a very high infection rate from the seed to the seedling immediately. But what you do have is a translocation of the organism into a new soil. And in time, as that organism prospers, and then we get a wound. We get a rainstorm, we get a hail, we get some sandblasting occurring, where we get an open wound on a plant, or even an insect bite, to where this organism can get into the plant, then off we go. And so it tends to be more of an environmental inoculation instead of a direct seed to seedling to a grown plant type problem. Well, it's in the plant. And even more so, once we have it in the plant, it stays over winter in that plant residue. And as you know, as that plant residue hits the soil, it stays there. It doesn't decompose. Our beneficial microorganisms are gone. And so it's a perfect condominium for these pathogens to hold up over winter, take their nutrient from the corn stalk, and then they're there to reinfect the corn at the first opportunity next year, as the bulk of the infection is coming externally. And this is the problem. I mean, we do not have beneficial soil organisms that are great for taking care of these wimpy bacteria anymore that are now becoming dominant. And we've got these no-till systems out there that don't put residue down into the soil, and you'll have higher Goss'S Wilt counts in no-till soil than you will tilled soil. And then we have people who grow corn on corn on corn on corn. That is the perfect storm for Goss'S Wilt. And crop rotation will help. There are varieties that are more Goss'S Wilt resistant than others. And so there's a series of things that we can do, but largely we can go back to good management practices, and we can put this organism back into check. And you've got to do it with crop rotation, plant variety, microbial inoculants. You've got to spray the proper microbes on the corn residue and kill this stuff over winter. You got to put it back in the ground. You got to let the good microorganisms take this stuff out, and you can get rid of this stuff. You can get it back into control, back into check. And we have got... Go ahead, Jim.
So I guess before we go into control, I want you to comment just a little bit more in depth on the storage part of it. So like your potatoes, are you saying that if I've got Goss'S Wilt in a field, I'm not only going to lose yield and test weight, but once I put it in the bin, I could lose additional bushels there too, right?
Absolutely. Absolutely. You have an organism working on whatever nutrient component is in that seed. And, you know, it's still there. And it can not only affect the present grain, but it has that potential to reinfect ground or spread it to other parts of wherever the seed is sold.
Now, if you talked a little bit about management, about breaking the residue down, comment a little bit on, is there advantage from GMO, non-GMO, non-glyphosate, using a biological with your starters, biological seed coatings? What are some management techniques we can use to start countering this?
Okay, you can't kill this guy with chemicals. If they could have done it, they'd have had it by now. You're going to have to control Goss'S Wilt with biology. And so the big chemical companies don't have a spray to fix this. I'm going to come back to this in a minute because of the potato industry out here. Salam that I work with, we make a lot of these really innovative, unique products. We have a test going right now on the Clavibacter michiganensis bacterial ring rot. And so far, we're winning the game hands down. But it's preliminary. and it's a biological component that we make that destroys the cell membrane of gram-positive bacteria. And so, but I want to go back to Jim's statement here, is how do we get back in control of these pathogens so that we don't lose them? And there's several factors. As Jim mentioned, you have conventional, you have GMO-type varieties. The GMO-type varieties, obviously the glyphosates and the herbicides, the glufosinate, those type of products, very damaging to any good biology in the soil. It doesn't matter if it's bacterial, fungi, protozoa, nematode, damaging across the board. The second thing is glyphosate or glufosinate, by their chemical action in the plant, are chelators. So they're stripping the trace elements and the positive cations away from plant growth and function. So we've obviously got a weakened, stressed plant simply because of the gene load, the chemical load, and then we've got the reduced beneficial microorganisms in the root system fighting off these pathogens and producing nutrients for the plant. So that is probably the worst of the scenarios that we have to deal with, is we have harsh chemicals, damaged soil biology, weakened plants. Conventional plants fare better. They're not nearly as stressed, they're not loaded down as bad. The chemicals that we use aren't nearly as harsh. That's not to say that we have great soil biological groups out there in our ground, because conventional corn is getting hit by Goss's wilt, is vulnerable, and it can take the same type of hits. We just don't need to aggravate this. The worse this gets, the harder it is to turn around. And so what we're looking at is, what are the proper management techniques to deal with this? And the first one I would look at is variety. There are some variety-resistant cultivars out there that do fairly well. The next thing is make sure you've got an adequate plant nutrient program from start all the way to finish. It doesn't do us any good to do really great until the 1st of August and then fall out of bed, because we're not going to finish well. But we can do a lot of very viable, very effective things to deal with the pathogens from a biological standpoint. And as Jim mentioned...
Can I interrupt you just a minute?
Yeah.
I want to go back to the nutrient thing before you go on to the biological. You mentioned falling out of bed late in the season, and I'd like to have you comment, where do we need the sulfur, and if we're short on sulfur, could this also be part of the equation that we really need to be cognizant of?
Yeah, it's a major player in your protein formations, and in corn, the plant uses a very small part of the total phosphate or sulfur uptake in vegetation. For example, let's just take a 200 bushel crop corn yield. We need 100 to 110 pounds of phosphate. Okay, we need way more potassium, way more nitrogen than that. But in relation to sulfur, we need almost 90 pounds of sulfur to get us that 200 bushel corn yield. And sulfur doesn't come in early into the plant. It comes, 90% of it comes back in reproduction. And it builds those amino acids, and it becomes part of the complex that these plants fill and bulk with. And if we have a microorganism shutting this plant down, we are not only losing that filling process, but if we're short sulfur, we're clipping off a sizable, up to a 20% part of our yield just on the absence of a mineral. And what we're seeing out here, and because we're fighting the same type of diseases, it may be a different plant, but the physiology is very similar, is we can have a good yield going into finish and then have these plants fall out of bed if the nutrient program isn't followed through, both with the building block minerals and with the trace minerals, and then the pathogen control. And I will reiterate this. This spring, I said, guys, disease control is going to become as important as your nutrient feeding programs for your plants. And I didn't think these problems were going to escalate as fast as we're seeing them escalate. I thought we'd be into this more in a few years. These pathogens are taking a huge toll out of our yields and our plant finished products because they divert the nutrients that we've got there and they're shutting the plant functions down. And so if a plant can maintain better health, it can develop within itself the plant secondary metabolites to fight these pathogenic organisms. But a weakened plant with no tools to build these protective compounds is completely vulnerable. And these organisms can walk right in and they take over. And so you've got to continue having NP and K uptake into the late reproduction stages. We know this from the crop diets that we show in our seminars. Is there's a second uptake of nutrients that's substantial in reproduction, and if they're not there, these plants are shutting down and they become even more vulnerable to the pathogens. So
now let's talk about you were going to talk about biology. So you're saying by getting the residue broken down with good biology and getting that decomposed, getting biology on the seed, getting biology in the seed furrow, maybe biology on the leaf, are these all things that over a period of time, if we back away a little bit from the glyphosate, that we can start rebuilding this biological balance in the soil that we need?
Absolutely. It's a given. We have done this over and over. We have a huge portion of the Idaho potato production under our management with these products that we use out here. All of our farms that are using the correct biological programs, whether it's a seed coat or whether it's part in furrow or whether it's a compost tea that we make special for this, used with minerals and microbes, we do not have one of our farms with one field that's contaminated. Our grower in Montana got the best award in the U.S. for potatoes in 2012. He was the top, highest quality seed potato producer in the USA. And he is 100% biological organic. And so we know for a fact over and over and over that microbes control the game with pathogens. End of story. And if you get this right, you can turn these pathogens around in a hurry. But we've got to deal with proper crop residue. We can't let these guys stay over the winter and be there waiting for a spring and then say, oh, we'll do a little bit in the spring and furrow to get rid of them. These guys are major dominant players in the soil, and we've got to take them out hard and heavy across the board. So if we get on the crop residue in the fall, we do some tillage to get it in, we put the right biology down, we will do a tremendous job in cutting this back by spring. Then we come in and we do the seed protection. We do the in-furrow applications. We put the biology down in the soil, in the root zone, not only the biology that kills pathogens, but it feeds the plant. We need the nutrient as well as the defense. And then we put it on the leaf. Because, again, on the leaf surface, the plants are continually putting out exudates, not only in the root system, but on the leaf as well. If there's no good guys on the leaf, and we get a windstorm or an insect that's carrying Goss'S Wilt and it bites a plant and infects it, there's nothing on the leaf to stop the bacterial infection. And off it goes. It's completely unrestricted. But when you have the good microorganisms on your leaf surface, there's no way for that pathogen to get to that leaf and survive because there's not a food source for him. The good guys will block him out and they'll kill him. And so biology is the way to deal with this on the plant, under the plant, and then getting rid of the residue through the fall and winter, coming back into spring and setting this up. And we can turn these tables very, very quickly. But we've got to have biology doing it. There's no other way.
Goss's Wilt up here in like I said, the upper Midwest, it seems like it really comes on strong when we have stress, and the last 3 years it's been drought. But there's always either a rain event or maybe a massive fog event for a couple, 3 days type of thing, or a lot of dew. And one of those, one or a combination of those types of environments just set that thing on fire, and then it just spreads like wildfire across the country. And it's quite amazing. But you can always see the stressed areas are the areas that get hit worst, and are there's more pink leaves in those areas, and those plants are really struggling. And the plants will, like you said, shut down, and it just starts working on one leaf, and it'll just work either down from the top or up from the bottom. I've seen it, work both ways. It doesn't seem to matter, and it can shut the plant down, very quickly, and definitely within a week. And we've also seen this year it attacked before we cut silage. And I had some guys that normally cut 20 ton of silage without a problem, even in drought, and they had 13 ton is all. And it really caught people off guard on the silage end of it. And I think what happened is that it took all the moisture out of the corn, out of the kernel, and it took the starch out of the kernel, and you're losing your weight.
Well, a plant does a lot of growing the last 4 to 6 weeks. I mean, it can put on, it bulks up, and that's when it really goes into the reproduction stage and the filling stage. And the good news is this organism is controllable. The bad news is conventional agriculture has slowly walked us away from the practices that allow us to control this. And we've got to come back to some basic, correct practices of nutrition and biological applications, and we can get back on top of this very quickly. And one thing I wanted to come back and just mention here is Salam has ongoing trials right now in these potato operations where we have, and we're monitoring them, where we have stopped the effect, at least to this point, of any damage from Goss's Wilt. Now, or it's not the Goss's Wilt, but it's a sister organism. It's the Clavibacter michiganensis sapindicus out here. We have stopped its effect. Now, that doesn't mean that we've completely eliminated it, but if we can stop it from taking out the seed and killing the organism, it's still in the soil where these plants came from. And to actually deal with that, you've got to go back and do a biological application. And so it may be a great Band-Aid, but it's not the permanent fix. You're going to have to use biology to get ahead of the organism in the soil, get it eliminated and put back into a very, very minor, insignificant role where it can't become the dominant pathogen and kill these plants and take out the tubers or ruin the grain seed, so that these crops are either major losses or they're fundamentally cut back on their yields so that it's anywhere from 30 to 70%, and it's happening. And so,
but also the corn that's coming out of this is not got. It can't be good livestock feed either.
Well, it can't even be good next generation stuff. You look at these organisms. I mean, the next generation has got only what it's got to work with to grow, and if you've got organisms working on this seed that's going to be next year's material, they're consuming the nutrients. What's the plant going to use? And so our seeds get worse and worse and worse, our plants get worse and worse, and the pathogens get more and more prolific.
So the message that I hear from you tonight is, number one, you better really talk to your seedsman where you're buying your seed and know how tolerant it is to this disease. That's really a good starting point.
It is.
And then nutrition, good mineralization is another very important part, and then the biology. Ken, at what point in the corn's life cycle over the season can it be infected, and where is it most vulnerable to the disease? Can it occur early, or does it occur later, or does it have to be wounded to be infected? How does this?
Yeah, typically it's a wound. And, there's some transmission from the seed to the seedling, but it's pretty low. They figure it's less than 2 or 3%. And that's not an economical loss by any means. But between leaf stages 3 to 5 is its most vulnerable state where we lose the highest yields. And that's in resistant varieties and non-resistant varieties. That week right there that these plants get infected early on is devastating. That's the worst time. Plants can get infected later, and the yields don't tend to be quite as badly damaged. But remember, at that 3 to 5 leaf stage, this plant is setting the number of rows around. And if it becomes infected, it's also going to come back, and that organism is going to affect from V12 to V17 the number of kernels it can put down the row. I mean, these plants know when they're infected. They know when they're carrying a pathogenic host. And they're under constant stress to try to deal with these. I mean, plants want to survive. They want to go into reproduction. They want to go into seed production. And so it's a fight. And these plants are under stress from these pathogens, and these early times are vulnerable. And so, Salam and I want to get this material that we're using on the potatoes that will kill this gram-positive bacteria. We want to get it on the seed. We want to get it in that root zone. If we can kill the seed, kill the bacteria around the seed and around the base of the corn plant, we don't have as high of infection rate from rain. If the plant gets wind damage, if we can clean up some of the immediate root zone area, we don't have that splash up infection potential going on with these early seedlings. And so there's a lot of things we want to try, and we want to see if one is this new compound that we're using to control this gram-positive clavibacter. We want to see what it will do on corn. Again, it's a great Band-Aid. It's not the fix. If we can stop it, and then we've made some headway. And so there's a lot of things that we're excited about trying this year, but it's, again, you've got to come to look at this as dealing with the pathogen and how do we remove it from our field so that they're clean.
And I think, Ken, we've got technology that we've put together over the years, and we have the biology for the soil and for the foliage. We have the BioMineral 75 with the 75 trace organic compounds. So we got a lot of the tools. We just need to orchestrate them and understand how this corn plant grows and what its nutritional needs are during the season and when, and then satisfy that based on yield goals that we want to set out in front of ourselves. So, I mean, the tools are there. It's going to be interesting. It's going to be interesting, and I really encourage everybody to come to our winter conference on February 6th and 7th, because Dr. Hubert is going to be there along with Ken, and I'm sure that he has a lot of additional insight and experience with this discussion that we've had here tonight, because I know he's tracing a lot of the critical pathogens that he feels raising havoc with a lot of our production systems, including this one here. So it's really going to be interesting to see what he's learned over the last year.
Ken, speak a little bit on the micronutrients, how important micronutrients are to, helping us survive Goss's Wilt and many other diseases. It's something that a lot of farmers, they don't even, think about.
Well, no one's really helping supply them the products. The co-ops don't have it, for the first thing, so they're not going to go out and tell a farmer he needs 65 to 70 trace minerals or more to run the plant functions. They don't have it to sell in the first place. And so what is happening is the plant immunity and its defense mechanisms are all built not in the proteins and the lipids and the carbohydrates, which are what the plant does first. They're built in the secondary primary plant the secondary plant metabolisms. And those are all basically put together by the function of the trace elements and the enzymes taking the nutrients and putting these different compounds in place for pathogen defense, whether it's internally or externally. The plant is capable of doing this, one, if we haven't bred the intelligence out of it, and the second one is if we've got the nutrients there to drive the enzymes to put this together. We've done so much genetic engineering right now that some of these plants don't have half a brain left, and they're not going to put these things together, and they're going to be perpetually vulnerable. And in my mind, going down that road will only produce more vulnerable plants, less nutritious food, more problems, but the chemical and the biotech companies always are there to offer another costly solution to a problem that they've already created. That is just another Band-Aid on the Titanic, guys. If we're going to get ahead of this, we've got to have proper nutrition, and it's not just NPK. It's 9 major functional building block nutrients. It's 70-plus trace elements, and they all have to be functional and usable by the plant. And then you build healthy plants that have got soil and airborne pathogen resistance. And because the components are there, if the plant can make them. Well, the next thing is we can go in and we can completely take out the residue. And so if we can spray the residue in the fall and it's completely gone by spring, not only is the residue gone, but the nasty pathogens are gone as well. And so these are vital processes that we have done over and over and over, and we know that they work. It's just that a guy can't be lazy and think that nature is going to work for him. You're going to have to do some management practices you're not used to doing. But it's the guys that are going to survive this that do this stuff, that make these changes and start to manage all aspects of their crop, the planting, the growing, the harvesting, and the residue. Those are all things that have to be done right, and you'll have a farm that will farm forever versus a farm you're going to lose in a decade or two, if you can even go 2 decades.
And Ken, again, we, along with you, we have put together what we call the Crop Advantage Plus program, which really lays this all out in a strategy based on what we're dealing with a particular farm, a particular field, and it lays it out in a way that it can be managed over the growing season with a plan without doubt, because we are looking at the plant and its nutritional needs, what we have in the soil, and so we know then what we've got to do to reach that yield goal and have the right microbial populations there in the soil and on the leaf and the right nutrition at the right time. So that vehicle is available.
Thanks, Jim, and thanks, Ken. I was wondering, are there any questions out there?
Yeah, I was going to ask Ken. He's got a program that him and Salam are working on for the potatoes. Is there a chance that we will be able to have something for the corn for this fall season?
This spring season.
Or this spring season, okay.
Yeah, we're going to get trials going because, again, we need to see what we can do with this. We know we can kill it. We can disrupt that cell membrane, but we need to know how effective what we're doing is and what what its limits are. And we don't know that. And again, this is a great Band-Aid if it continues to work, but it is not the solution. But at least we can try to stop it to a point where we can get through a crop season, have a healthy plant, get a great harvest, then come in and deal with the soils, deal with the crop residue, and start to make these changes. Now, there's also opportunities to put down the correct biology this spring. So as you go out and we spray these fields, we can do some biological remediation through the spring and summer and going into fall. So, I mean, there's opportunities for us to start to turn the tide on these prolific pathogens that are really starting to take us to the mat and really damage our profits and our soils and our livelihoods.
But Ken, this is Dave. Tell everyone what we're thinking of for this coming year is to actually treat the seed with that product.
We want to try, we want to try to put some distance between these organisms and the root zone and the immediate area around these young plants. I mean, these plants, they get so badly. V3 to V5 is the worst stage of infection, and these are just small plants. And if we can create some type of barrier just to get us past that, to help these plants, pathogen-wise, nutrition-wise, we want to do everything we can to see how we can get a leg up on this as fast as we can. We don't have the answers, but so far we're staying ahead of the problem out here, and we need to transfer it into corn and see what we can do. So we're going to be looking for some people to help us with some tests to see how effective this product is.
Okay, sign me up.
You're on, Doug.
All right, sounds good.
Ken, this is David. Would you also agree that part of the whole overall program should be we need to be looking at a complete soil analysis so we can start to look at the balance in your soils? If we have some trace elements that maybe are short or we have one or two that's in excess, there are some things that we could do to help that correct.
Yeah, there's another program that we're going to introduce here at the Winter Conference. And it's not just a mineral look at your soil, it's a biological balance of your soil. And then you'll be able to see why we have these pathogens that are so out of control. We're used to looking at a soil test on a mineral basis, but the biology is just as crucial in so many ways as minerals, and we never look at that. And so we're putting together now, and we'll have it by Winter Conference, a soil biology calculator that we can plug in and see what we've got, see what we don't have, where we're short, where we're too high, and we'll be able to go through and show imbalances in biology just as we're doing as imbalances in minerals. And there's not a place on the planet you can get that information yet. But guys, it is so critical that you look at this, because this is the key to unwinding so many problems that we've just slowly kind of phased into over the last couple of decades with this mode of agriculture that we're adopting. It's problematic, and it's going to get worse, not better.
Ken, it's not only in the crops right now, Ken, but we've got this PED virus going through the hog industry like a wildfire. And what I took away from the meetings I've been at the last couple of weeks, the South Dakota Pork Show, they had a meeting on this. There was 300 people in the room, is that if you have a sow herd, there's probably no way you're going to be able to keep this out. It really sounds like everybody's going to be hit on this thing, and it's going to be devastating to the hog industry because it takes out that whole group of pigs, and they're not sure that these herds can't be reinfected again with it.
Sure.
So, I mean, we're not only seeing it in the crops, but we're seeing it in our livestock because of, a lot of what we're feeding them coming out of these fields.
Well, and just as we have problematic pathogenic conditions in our soils, when we use the chemicals that become part of the plant that goes into the animal feed that eliminates the good biology in the gut or the rumen or the GI tract of our animals or humans, again, we have an imbalanced biology, and our immunity is largely developed or given to us through our digestive system. And so we compromise the biology, you're going to have reoccurring and more devastating health issues among any organism population. It doesn't matter if it's plants or animals or humans. And it's nutrient-based. It's not that we don't have an effective immune system. If we simply don't have the components to deal with that and let our immune system build these compounds within us that fight these organisms and keep us healthy, we're vulnerable. And a hog is no different than a human. I mean, we have really close GI tracts. And, you know, this nutrition is so critical, and good biology in the gut is so critical. And that's our defenses against these pathogens, because the good Lord, He's not going to let us kill every pathogen on the planet. They're there, they play a role, they enhance the gene pool, but when we let them get out of control, they really take us down hard. And we can do better at our control mechanisms, getting the nutrition back in our plants, getting the right biology in the soil, in the gut. We can do better than we're doing. We've just kind of gotten lax and lazy about really paying attention to the details of our stewardship. I mean, doggone it, guys, we're farmers, and we need and we can do better than we're doing. And it's just, but it's understanding, and it's knowing how to do it and how to go about it, and how these natural laws are all put into place, and you can make a huge difference. And sooner or later, someone's got to step forward and do this right, or there's not going to be many organisms left on this planet that have longevity. Because we're not getting better at anything, guys. Our animals and our human populations are going down.
And Dennis, before we close out, thank you very much, Ken, for those comments. I'd just like to, again, just encourage everybody to come to our winter conference. I think we got some excellent speakers with good content and topics. The other thing I'd like to mention is all of our teleconference calls, like tonight, are put up on our website by Monday or Tuesday the following week. So if you want to go back or tell somebody that would like to listen to this, it'll be up on our website. So I just wanted to mention that, Dennis.
Okay.
Hey, Ken, this is Aaron. I got one more quick question. You were talking about how Goss'S Wilt is more prevalent in a no-till system. How would you deal with a farmer who's already invested in all the no-till equipment? What would you recommend as far as control when it comes to that? Because it's harder to control residue in a no-till system.
It's very difficult, and that's why that no-till system is actually environmentally pleasant to these organisms. But you know, there are minimum till systems where you can get dirt on residue. Part of managing this in a no-till system is you're going to have to get some good doses of beneficial microorganisms, and I'm talking broad spectrum. I'm talking hundreds of thousands of species of bacteria. We're talking tens of thousands of species of fungi. We're talking protozoa and nematode. You can still spray that and put it out and get some relief if he just refuses to till. But you got to realize in that system, it's tilted towards the pathogen. And, you know, these guys don't want to till. I understand the carbon sequestration and that whole thing, but sometimes you just have to do what you have to do if you're going to get it on top of these pathogens. And you can apply the biology from the top down, and it's a little slower to work. Any of your residue that's above the ground, it's not the place where it decomposes. But we can get the soil, we can get the biology into the soil and have it start working down, it'll have some positive effects. But the best thing is a little bit of minimum tillage, get the dirt, we spray the residue with the biology, we get the dirt on it, and that whole system is inoculated with the good guys, and they will clean her up from fall to spring. And That's the optimum. Short of that, we've got to spray what we can spray and put it on heavy and hope for the best. If they won't, do some minimum tillage with this residue.
Well, that's what I did, Ken. I plowed for the first time in 20 years. So I plowed my corn stalks over and hoping that's going to help some.
It does. They can't. There's no biology that lives up in the air that's going to eat those. And guys, you got to realize it's not the bacteria in your soil that can eat yellow, dry corn material. Plant. It's not. It's fungi. And I can already tell you, because I've spent tens of thousands of dollars on soil biology tests. Guys, you don't have enough fungi to do the job, or the corn residue would be gone. We've got to get the fungi back in there. That's the organism that eats that dead, yellow, dried out plant matter, not bacteria. And those chemicals that we've used take out the fungi in a heartbeat. But we can put it back. We can get those new organisms onto the residue, into the soil. They'll go to work, and that broad-spectrum group of biology will put those pathogens back in check. They'll kill them and take them right out. They won't tolerate them. If we get enough good guys, they will control the bad guys.
Say, Ken?
Yeah.
How much time in the fall after you spray your corn stalks do you have to work them?
The faster the better. The faster the better. If you can spray them and get them in within a day or two, that is optimal, and you will have the best decomposition. If you spray the corn stalks, let them sit for 2 weeks and turn them back in, you're going to get half the digestion rate. Because most of these microorganisms we're putting out there that are so beneficial, they're ultraviolet sensitive. They're soil-borne guys. They're not out there getting suntans on the beach. These guys want to burrow down, and they live where it's dark. And so those UV radiations, they're hazardous on a lot of these guys. So we put them out, get it on the residue, get it turned under, and these guys are home free for the next 6 months. They are kicking butt, eating dinner day and night. They're taking the residue apart, and they're killing pathogens. And they're going to control that environment. It's the same thing we do in hog lagoons. We put in a culture of microorganisms that completely changes the biological profile of that entire pit or lagoon. They're going to come in. They're going to be the dominant guys. They're going to control the decomposition, and they're going to take out the pathogens, period, because they don't tolerate them. And they'll put them back in check to where they're not even a factor. And so the great job with biology is these microorganisms know what to do, but when they're not there, they can't do their job. And when we put out microorganisms, they need a splash of minerals with them, because just like any other organism, that's where they get their energy. They've got to have, for a microbe to reproduce, it's got to have its complete mineral profile intact. It's no different than a plant. When a microbe runs out of a mineral, it quits reproducing. When a plant runs out of a mineral, it shuts down. And so minerals and microbes always go hand in hand, guys. They are a magical combination. And you can correct a lot of problems with those two things.
Ken, one more here. I know we're running a little bit over here, but we used about 1.5 gallons of bio-release on ours in starter and side dressing. We had like a 200 bushel residue corn crop, but just a little over 100 bushel because of Goss'S Wilt primarily. How much action are we going to have? And we've sulfured everything once, and then we chisel plowed it, so there's quite a bit of dirt on everything. How much residue reduction do you think we'll get just from the bio-release?
The bio-release is going to kick butt. This is a test that we did with Pioneer over in Illinois in 2010. These guys didn't want to put out any brood biology. They just said, look, we just want to be able to take and put something on our soil, spray our residue, and turn it under. We had, with 1 gallon of bio-release, we had 100% crop residue decomposition by the 1st of April the following year. They put this on in October. Because what happens is bio-release has a fungal stimulant in there that grows fungi like nothing on the planet. Well, you guys have a little fungi. You don't have a lot, but when you put bio-release out there, you get a truckload of fungi that's native to your soil coming back and growing. And those fungi are what take care of these plant residues. Now, we don't necessarily have a great diversity because over time in our farming practices we've killed a lot of species. But what's there, what we can bring back, will still do you a great job. It's better if we can put out microbes with the biorelease. And what we found is in our Iowa tests, we could put out half the biorelease and microbes and get the same job done. We could completely take out the residue by spring. And we not only took out the residue, we had earthworms where they haven't seen earthworms for 30 years. And to have an earthworm, that means you've got to have all the living systems underneath the earthworm to support it. Now, they weren't big earthworms, but it meant that we had, from the earthworm, we had the macroorthopods, the microorthopods, we had nematodes, we had protozoa, we had fungi, we had bacteria. When you have one of the top feeders in the food chain living, that means everything beneath him is there to support all the other life systems that these guys depend on. And they said, we've never seen earthworms. Where did they come from? Well, they're there. They're just dormant. But when you activate these biological systems, these life forms come back, and they start to do what they're designed to do. But you got to feed them. You got to have a nutrient there for the good guys. So I would expect, Jim, you'll have some pretty decent residue decomposition by spring just because of the biorelease that's out there.
We put it on in May with starter and in June with side dress, so none of it was put on in the fall.
Well, some of it will still be there to help. I mean, you were growing fungi. You were growing some good guys. The problem is, you know, Goss'S Wilt will come in and they'll shut these plants down, and you can see that the yield is coming. It'll be there in July and August, and it won't be there in September. And
I saw that.
And so we got to get ahead of it, but we can take these organisms out of our soil. And the other thing is we can do these foliar sprays with biology on these corn plants when we put on our minerals. When we come in at V3 or V5 and we spray a foliar nutrient, we can put biology in there, guys. And again, that's a defense mechanism against the splash up from the soil or the airborne Goss'S Wilt coming in. So,
well, we're well after 9 o'clock now. We probably should close it out. Just wanted to mention that our conference is on February 6th and 7th in Albert Lea down at our headquarters, and we have some incentives this year. There'll be a 5% cash discount that's prepaid by February 21st if you attend the conference. There'll also be a 10% cash discount off of seed coating, again prepaid by February 21st if you attend the conference. So there's a couple good incentives. The Crop Advantage Plus will be reduced to $10 an acre as well versus the normal $12 an acre. So some also 10% off of feed additives, manure treatment products, and the silage and forage enhancer as well. Again, you have to attend the conference and prepaid by February 21st. I'd like to thank everybody for listening in and for the good questions. Excellent job there, Ken. Really appreciate it.
I made it all up, Dennis.
Well, we knew that, so. But thank you for listening. We'll hope to see you at the conference, and God bless.